Hi everybody, we're talking about inferences with two sample means. What we're going to be doing in this screencast is testing claims using technology, specifically our TI-84 graphing calculators. We're going to be using the two sample t-test and the two sample t-interval on our graphing calculators. So specifically what we're going to do in this screencast is we're going to conduct a hypothesis test of a claim about two independent population means. We're going to be using the p-value method here. We're going to take that same example and we're going to solve the problem using a confidence interval estimate of the difference between the two independent population means. In both of these examples, it's the same example done two ways. We're going to be making a conclusion about the claim. So there's some important notation in this section. Remember, we're going to have two samples, two populations in these examples. So we're going to denote those using subscripts. So we'll use 1 as a subscript for the first population and 2 as the subscript for the second population. So mu1 is the population mean. Sigma 1, sigma sub 1, is the population standard deviation, and n sub 1 is the size of the sample. We also have a sample mean, which is x bar sub 1, and our sample standard deviation, which was s sub 1. Just want to make sure you're familiar with all this notation. So let's look at our example. So you can read through this example. I'm not going to read it to you. But this is an example where you are evaluating whether or not this specific treatment of pain using magnets to treat pain is going to be effective or more effective than not using anything to treat the pain or using a placebo. So we're asked to use a 0.05 significance level to test the claim that those treated with magnets have a greater mean reduction in pain than those given a sham treatment or a treatment similar to being given a placebo. So we're going to do that first, and then after we're done with that, we're going to look at that confidence interval. The statistics are written here. So they give us the statistics of those in the study that were treated with the magnets and those in the study that were treated with the sham. So let's look at this process that we're going to have to go through. So to do this hypothesis test using the p-value method, the first thing we're going to need to do is identify the null and alternative hypotheses. Then we're going to test the claim using the two sample t-test on our graphing calculator. And we're going to take note of that significance level. So we're going to look at the information we get on the calculator, compare it to the significance level, and then make a decision on whether to reject the null hypothesis or fail to reject it. And once we have that all done, then we'll state a conclusion based on the claim. Okay, so back to our example. Here are the statistics, which I got in the calculator. I'm going to show you how to do that in a second. And here are our hypotheses. You should be very familiar with this by now. We've been doing this for quite a while. So remember, our null hypothesis is always an equation. It always has the equal sign. So the null hypothesis is that the means from the two groups are the same. And the alternate hypothesis is that the mean from the first group is greater than the mean from the second. Remember, we're testing the claim that those treated with magnets have a higher mean reduction in pain than those treated with the shams, which is our second population. So mean 1 is those treated with magnets, mean 2 is those treated with the placebo. Okay, so how do we do this on our calculator? So once again, we're going to press that stat key. We're going to toggle over to the tests menu, and we're going to conduct what is called the two sample t-test. So two sample t-test on your calculator. It's going to ask us for data or statistics. Some of the questions in your homework, they're going to give you the data, where they're actually going to give you the list of the information, and you can put that in list 1, list 2, like we've done before. But here we're actually given the statistics. So I'll press enter. And then I'm going to go through and enter all these statistics, which I did before I started the screencast. So X1 was 0.49. The standard deviation from the first population is 0.96. The number in that group was 20. And then with the second population, the mean was 0.44. The standard deviation was 1.4. And the number in that group was 20. This is a two-tailed test. Remember that. This is a two-tailed test. So, and we're testing the claim that mu1 is greater than mu2. So that's the choice you want to put in the calculator. So make sure you highlight the correct choice and press enter. So we are doing the greater than or right-tailed test. It's going to ask you, the calculator is going to ask you whether the data is pooled or not. You can read about this in your book. Your book in this chapter will talk about whether or not you, or when you pool the data. It has to do with whether or not you know the population standard deviations. And in real life, you don't usually know the population standard deviations. So for all of the problems we're doing in this class, you should choose no. And then we're going to press calculate. And that's where I got the test statistic, T, which is 0.132 rounded to 3 decimal places. The p-value of 0.4480 rounded to 4 decimal places. Alpha is equal to 0.05 was told to me in the problem. Remember, that was the significance level. So then what would be the conclusion you're going to draw? You've done this problem several times. So what conclusion can we draw? Well, since p is high, remember that p-value is larger than alpha. Since p is high, null must fly, which means we're going to fail to reject the null hypothesis. So the conclusion what we draw, using the claim from the problem, remember the claim is that the treatment with magnets is greater than the treatment with the placebo. So our conclusion is there is not sufficient evidence to support the claim that the magnets are effective in reducing pain. Okay, let's look at that confidence interval method now. So we're doing the same problem, but this time we're going to do a confidence interval. So once again, press stat on your calculator, toggle over to tests, but this time toggle down to 2 sample t interval instead of test. Once again, it asks us for the data or the statistics. We're using the statistics. So the data is, or the statistics, I should say, are going to already be in there because you just did that 2 sample t-test. So it just copies that back into the interval program. The one thing you have to change is this level of confidence. The level of confidence here should be 0.9. Where does that come from? We've done problems like this before. Remember, the confidence level is 1 minus twice alpha. That's because this is a one-tailed test. Remember, if it's two-tailed, you do 1 minus alpha. Since this is a one-tailed test, we're going to do 1 minus 2 times alpha. So 1 minus 0.1 gives us 0.9. That's where that confidence level comes from. And then we'll press enter. And we're going to go get our interval. I have that written here. So the interval goes from negative 0.592 to 0.692. I should point out that the interval represents the difference between the two means, mean 1 minus mean 2, mu1 minus mu2. Remember from before, since the interval contains 0, since 0 is in the middle of these two numbers, there is not sufficient evidence to support the claim that magnets are effective in treating pain. Remember, if mean 1 minus mean 2 is 0, that means there's no difference in those means. So since the means difference could be zero, that's the instance where we fail to reject null. That means there's not sufficient evidence to support the claim that magnets are effective in treating pain. Okay, good luck.